Hello friends, welcome to Packet Pulse. In this video, we will break down the difference between forward proxy, reverse proxy, and the load balancer. I'll explain what each term means, how they work, and where they are used in networking and IT systems. If you find this video helpful, don't forget to subscribe to the channel for more easy to understand tech tutorials. Your support means a lot to me. So what is a proxy? Proxy is someone who represents you on your behalf. You must be knowing that meaning a lot. Now, by looking at this traffic flow, let's make us understand an analogy of a restaurant and how the proxy works. The client machine is you as a customer visiting the restaurant. The proxy server is a waiter, and the internet is the kitchen. Okay? So you are dining at the restaurant and you want to place the order. Do you directly go to the kitchen to place the order? No. You place the order to the waiter. The waiter in turn goes to the kitchen and places the order on your behalf. Once the order is ready, the kitchen gives the order to the waiter. They don't know whom the order came from. He came from the waiter. So it goes to the waiter. The waiter then serves you on your table. So in this scenario, the waiter is a proxy server. Okay, let's take an example of this slide, wherein we've got three clients who are sitting on the left-hand side on an enterprise network. We've got proxy, we've got the internet, and these clients want to browse the sites which are on the right-hand side, which are outside your enterprise network. What do? The client, all traffic on the enterprise network, remember, has to go via the proxy. If that's a requirement of an enterprise network, you cannot just bypass the proxy and go to the website. You will not be able to go to the internet without going to the proxy. So all these requests have to go via the internet. So now let's see how step by step it works out. For 1.1, who wants to visit a site, he first browses, and then the request first goes from 1.1, it comes to the proxy. The proxy will see the request. Okay, the source is 1.1.1 here, and okay, it wants to go to abcd.com. What it will do is it will forward the request on its behalf to abcd.com. Remember one thing, when abcd.com is receiving a request, it sees that the source is 4.4.4.4, which is the IP address of the proxy, and not 1.1.1. So what happens is when it receives a request from the proxy, it responds back to the proxy. It will not respond back to the client directly. It responds back to the proxy. So once the response comes back to the proxy, what the proxy will do is it will look at this table. So if you look at this table, okay, it will see, okay, well, ABCD is the destination from where the traffic is coming. Who wanted the traffic? Okay, 1.1.1. So what it will do is it will forward this request to 1.1.1. So 1.1.1 will be able to view abcd.com. Similarly, the same type of request happens for 2 and 3. So you can see the request coming in from 3, a populating table on proxy, going to PQR, sending a response back to proxy. Proxy will give the page back to 3.3. So this is how normally a proxy works, a forward proxy, whenever you're sitting on the enterprise network. So what it's doing, it is shielding the enterprise from the big bad internet. That's what it's doing. Now let's discuss in brief about the advantages of a forward proxy. What's the advantages? First is privacy and security. As we all know, when we are sitting here and we want to browse the internet here, we have to go through the proxy. So the proxy is protecting our privacy and security. We cannot go here. If we go here, they will know who is coming to us. From your IP addresses to your browser cookies to everything will be leaked, and this might be misused on a later time. So privacy and security is the number one. Number two is caching and performance. So what's caching and performance? So let's draw a similar diagram here. You are sitting here, the proxy is sitting here, and the website's here. So let's talk about a website saying Amazon.com. I am placing a request to the proxy. The proxy will first check whether the request for Amazon.com is in its cache or not. Okay, so if it's in this cache, it will give the page back to the client or the user. However, if it does not have caching or the page present, the static page, it will go to Amazon.com. The Amazon.com will give a page back to the proxy. The proxy will in turn return the page here. So what it's doing in the meantime is the proxy will be caching the static page of Amazon.com. So next time again you come to and you want to go to Amazon.com, what it'll do? It'll come here. Then proxy will say, okay, I think I have Amazon.com. I don't need to go to website. What it'll do is it'll give a response back from here. Think about it. Another user from the enterprise here, he again wants to browse Amazon. He just comes here, the proxy will look at the caching, and then it will give back the page to you. So what it is doing is the caching performance is actually increasing the performance of the page that you're receiving back. So that's the caching functionality of the proxy. Third is regulate the internet usage of an organization. So since the proxy is blocking all the requests that are not, you're not supposed to browse all the websites, it regulates the internet usage of an organization. The ISPs are equally responsible. You've seen that a lot of ISPs block sites from certain countries. You're not able to, you cannot visit certain websites. Those all sites will be blocked by the ISP using their proxy. So this much is the information that we have about proxy. We can discuss more on the comment section. We can discuss more on next video. But as of now, on a brief overlying, this is what I'm going to discuss. Now let's discuss about reverse proxy server. First of all, why is it called a reverse proxy server? Reverse. We just talked about forward, now reverse. The only reason why it's called reverse proxy server is where this proxy is sitting. Earlier, the proxy was sitting here in the front of the client. It was protecting the client. Now, the proxy server is protecting the end servers. So that's the only reason why we call this a reverse proxy. Earlier in the days, there was nothing called reverse proxy. Everything used to be called as a load balancer. That's something that we'll discuss going forward. But yeah, this is why it is called a reverse proxy. So let's take an example of a client, a user sitting outside at home and trying to browse youtube.com. In this case, the youtube.com is a Google enterprise. So all these servers are YouTube servers which are sitting in a YouTube data center or a Google data center somewhere in the world. So we are not exposed. These IP addresses of these servers, the 4 servers which I've given here, are not exposed to the users. So what is exposed to the user is the IP address of the reverse proxy. So when I do a reverse proxy or an NS lookup of, if you go to your command prompt, type NS lookup youtube.com, the name will be resolved and you'll get an IP address. So when you place a request or open youtube.com here, what happens? First, it will be directed to this IP address, and this IP address is hosted right up here. So a user who's sitting here, go through the internet, will hit the server here. So it's youtube.com. So what does the proxy server do? It will look at the request and it will forward the request to one of the servers. The same thing. The server will keep a response back. This proxy server again has a table similar to what we discussed of a forward proxy, and then it will go to the client. So depending upon what kind of request comes or when the request comes or the volume of the request, this guy, the reverse proxy server, will direct the request to the one server or another. There are multiple load balancing methods that the reverse proxy server uses. So that is why it is sitting in front of this. So it can be a round robin, it can just send to one. There are numerous others. We'll discuss about the methods of round robin or the load balancing methods when we talk about load balances. So this is how a reverse proxy works. So it is protecting the end servers from them. So now, what are the advantages of a reverse proxy server? First thing, improved performance and scalability. When we talk about improved performance and scalability, what does scalability mean? The ability for us to increase or decrease these backend servers whenever needed is called scalability. Suppose there are less traffic here. What do? I need only two servers here, or in fact, only one. And when the volume of traffic increase, what I will do is I will increase the server more and more and more. But is it impacting any of the users while I do the scalability up and down? No. Why? Because I'm hitting only this IP address. The traffic is coming here, and all this traffic, this server or the reverse proxy is forwarding to only the available servers which are on the network. Next point, improve security. Because we are not exposing our end servers, the proxy server is coming in between the servers and the client. Monitoring and logging. Every traffic that passes through the proxy servers are being monitored. The reverse proxy server or whatever servers are being passed are monitored. It logs the traffic. It will know what traffic is coming to where and how, what is the request. So that's monitoring and logging. Privacy protection. So in case of privacy protection, will this client who is sitting here know the IP address of this? No. So this will only know the IP address of this guy. So hence the IP addresses and all the other details of the server are protected by this proxy server. Next, caching. All proxy servers do caching functionalities, which we have already discussed in the forward proxy, SSL termination, and load balancing. Load balancing is already discussed. I can still talk about this here. Load balancing, the traffic comes here. So this guy will decide on which server to send traffic to, A, B, C, or D. And then SSL termination. So SSL termination basically is when there's a secure connection coming from the client to the server, the SSL is terminated here. Only this part is secure. Okay? It terminates from here, and then it takes that overhead of the termination because you need certain performance criteria to be met for SSL to be terminated. So SSL is terminated here, and from here it validates that okay, the client and this connection is secure, and then the SSL is terminated here, and then it forwards the traffic back to here. The SSL does not, if I am a secure connection, it does not come from here and it does not go to this end connection. No, SSL terminates here. The term of SSL termination is called SSL offloading or certificate of offloading. So now let's talk about load balancers. Load balancer is exactly the same as the reverse proxy. It does the same functionality as what the reverse proxy does, SSL termination, load balancing, everything. The reverse proxy term came in very recently, where all these small companies or companies like Nginx and all, they use reverse proxy terminology. But earlier, there was nothing called reverse proxy. It was just, proxy and the load balancer. So now the reverse proxies come into picture, but it does this. Load balancer does the same functionality as reverse proxy. It can do SSL termination. It can do, load balancing. It can do caching. It can do everything as what the proxy can do. But yes, the terminology is different, and we've got different, products for different ones for proxy as well as load balancer. So coming to load balancing, if the same thing, the same concept applies here as well. The client from the outside is trying to go to youtube.com, the same concept. So a client wants to reach a server, it hits the virtual IP address, the virtual IP address of the load balancer. The load balancer decides on which of the server to forward traffic, depending upon the type of load balancing that is set. So there are many types of load balancing. Out of them, three types of load balancing are used very frequently. The first type is least connection. What is least connection? Least connection is, suppose, for example, you've got four servers. This has two connections. This has, okay, let me change to a red one. So this has two connections. This has four. This has five, and this has one. So if a least connection load balancing is configured here, the next request that comes in from the client, the load balancer will read which has the least number of connections onto the server. By looking at this, it is one. So this request will hit this server. So that is called least connections. The most popular one next is called round robin. Round robin connection. The first request will go to this server, irrespective of what the load is. The next connection goes to this server. Third connection goes here. Fourth will go here. And the fifth will again go here like this, like, one after the another. So that is called round robin. The next one, what normally organizations do to change the traffic is the weight. They'll give a weight, like how much traffic. Suppose I have 100 connections coming in. I will decide, okay, I will send 20% to this guy. I will send 50% to this guy. I will send 10% to this guy. And the remaining, this is 50, 10, 15, and we've got remaining 20. So I'll send remaining 20 to this one. So the number, if we have 100 connections coming, 50 will go here, 20 will go here, 10 will go here, and remaining 20 will go here. So that is how the load balancing works. Okay, so this is the final slide, the consolidated slide that I've created, wherein it will show you the proxy, where the proxy is sitting and where the load balancer is sitting. And in terms of the client, so since the client is here, so if the proxy is sitting here, this is the forward proxy. Okay, so you are in enterprise A and you want to browse something which is in enterprise B. So what does that mean to you? So if you're in enterprise A, you go via the proxy, you go via the internet, you reach out to the load balancer or the reverse proxy of the Google Web Enterprise. And then the load balancer or the reverse proxy works as it's supposed to work. It will terminate the connection here, and then it will forward the connection to the servers, respective servers. So this is how the consolidated diagram should look like or looks like. So you're sitting on one enterprise, you're going to Google. If somebody on Google is trying to browse any other websites, they would be sitting on this side, and the server party would be sitting on the right-hand side of this diagram. So this is pretty much it, right? So hope this video of mine clears your doubt about load balancing, proxy, and reverse proxy. If you have any questions, please do comment, and I would be more than happy to answer the questions as soon as possible. I hope you like this video and this video was helpful. In case the video was helpful, please do not forget to subscribe to the channel for easy to understand tech tutorials going forward. Your support means a lot to me, and I will start creating more videos like this, and I'm always open to feedback. In case you need anything else or any improvement on this kind of videos that I'm making, please do comment, and I'd be more than happy to listen to your feedback and work on that. Thank you very much. Thank you for watching.